we will have Professor Ting Zhu from Computer Science and Engineering to talk about his, smart grid security.
All right. Good morning, everyone, and thank you for the invitation. I'm Associate Professor in Computer Science Engineering Department. Today, I will talk about sustainable and secure systems. So as a system researcher, I actually done a lot of research in different topics and different directions. So today I will mainly focus on the renewable energy and the sustainability technologies. So this is a little bit earlier work we have done. So the first work basically is try to flatten the peak demand. And this is done in 2000, like more than 10 years ago. And the basic idea is very simple. Just try to apply large batteries and charge a battery during the off-peak time and then discharge a battery during the peak time. But this one, we won the Test of Time Award. That's what I always told my students, do a research earlier on a new topic, right? So even though the solution is relatively simple, but it's important and it can save like 10 to 15 times of savings. Not that significant, but also can reduce 20% of peak time. But we are the first one doing that. And then follow up, we also combine the renewable energies in the system. So assume in a small home, you have a solar panel or wind turbines. Then if we consider about renewable energy, how to charge and discharge, and then we can also reduce the electricity bills on that. By doing that, we can reduce this savings around the 20% of savings, minimize the electricity bills. So this is a talk about the individual homes. So we also envision in the future, we have a lot of homes, they are connected together, and each individual home, they have the solar panels on it. Then we can have this so-called microgrid system. So in this research direction, we have done a lot of research in this field. First, we build high quality energy meters, try to monitor the power, voltage, frequency, etc. I will talk a little bit more about that. And on top of that, we have a middleware layer to do the data collection and data cleaning. And on top of that, we will have the demand scheduling, real-time data and energy management, and energy sharing among individual microgrids, and the privacy-related topics on that. I will talk about more detail. So let me first talk about the hardware part. This is the power meter, power quality monitoring meter we built, and it can be like plugging into the power outlet, and it can use your smartphone as an app to monitor the voltage as well. So we also compare our power meter with a commercially available like e-gauge device that can be plugged in the this is a power outlet, and each like individual each individual circuit, we can have the e-gauge meters to monitor the high quality power consumption, frequency, etc. So this is the result we got. So you can see if we zoom in over here, this is the red line is our power meters measurement results, and this is a commercially available device, and the e-gauge is also a commercially available device. So this is a table compare our power meter with e-gauge device. So we can see at the frequency, voltage, frequency, and the phase, they all like at least equivalent to the commercially available device. But in terms of cost, our cost is only like $50, and it's 10 times less than e-gauge. At that time, it's like more than $600, and definitely also much less than like existing commercial device on that. But we can achieve a high quality, and on the same time, it can be plugged in the individual homes. So build on top of that, we also have some very interesting observations on that. So this is the research conducted with my student. He collaborated with his neighbors. So we have two homes. So I want to clarify. So as an academic researcher, we don't have a lot of resources, but we try to do a lot of like system research and make it impactful. So this one is like these two homes are under the same transformer, and then we can ask one home to like don't consume anything, like in the middle of night. So that one home, it doesn't consume, turn off all the other important appliances, and the other home try to turn on the water heater, etc. So you can see when the voltage increase, oh, I'm sorry, when you turn on some like power consumption device, your neighbor's voltage will drop. It has some kind of similarities to that. So you may also experience like when you turn on the microwave oven or you turn on the space heater, your light will dim a little bit, right? So based on this observation, you may say, oh, this is a kind of very obvious. But built on that, we can utilize this power and voltage relationship to flatten the peak demand in a microgrid. So how can we do that? Assume here is we have multiple homes connected together, and you may have the water heater on, and the other your neighbors may have a water heater on. If they are not synchronized, if they are not like offset with each other, you will create a peak, right? If you add them together. So we have used these power meters, try to continuously monitor the power consumption voltage online, and then we can try to do some backoff to do like a distributed scheduling, then can flatten the peak demand. And the challenge is here is how to back off without affecting the user's comfort. And the second question, then in order to do that, we need to build some kind of a thermal models of water heater. Then we can predict the heating durations and the user behaviors as well. So our goal is not affect the user's comfort, but try to do the preheating, something like that. And the second challenge is how can we cooperatively to do the backoff among different homes without affecting them. So the basic idea over here, if you don't back off too much, you can still create a peak demand over here. So we want to develop a distributed algorithm, scheduling algorithm to deal with that. So this is a specific system, and we have the voltage and power. We can build the power voltage models. This is basically will give us how much demand in the microgrid. And we can also, based on the temperature and hot water usage, we have the water heaters model. And then we can develop a distributed scheduling algorithm of that. So I will briefly talk about these three models. First, we talk about the power voltage model, and we build a model for 2 homes. And then we can extend for N homes connected in microgrid. And for the water heater models, we consider about the hot water usage, standby loss, heating, and then we can calculate how long we need to heat to use the power to heat the water heater. And then we develop a distributed scheduling algorithm. The design goal here is like we want to flatten the peak demand without affecting the user's comfort. And we need to calculate how many homes should turn off the water heater and how long they need to do the backoff, etc. So we evaluate our system by deploying the water flow meters and the temperature sensors. And also we use our platform prototype device. And we compare our mechanism with original power consumption if we don't do any scheduling on that. So this is, if we don't do the scheduling, this is the power peak demand over here is around 90 kilowatt. And if we do our scheduling algorithm, we can significantly reduce the peak demand by around 29%. So this is if we zoom in, we have like 10 different homes. So this is based on the result we get from different homes. And especially during the morning time, you can see they have like, if we don't do the distributed scheduling, everyone want to heat the water heater at the same time to take a shower before going to work. And by using our scheduling algorithm, you can see the peak time can be split a little bit. So build on top of that, so far I only talk about this part. We also have done a lot of work that if we have multiple homes, we can have the real-time data management, especially we talk about the larger microgrids. So, well, if we extend it further, then we need to do real-time data management. And if the data, how can we deal with missing data if we don't have the data coming in, and if the grid is becoming bigger and bigger, then we still need to make a decision, and given there's a missing data over there. And then we also, then on that case, we need to consider about the demand scheduling, and also we also need to consider about the local generators, because in most of cases, the renewable energy may not be sufficient enough. So you may be surprised, like in California, it's okay, but in Ohio, like we may run out of renewable energies, right? In some, especially during the winter season. So we have done a lot of work on that. So this is just to summarize what we have done in the microgrid field. So far I talk about the energy sharing, etc. So for the privacy part, actually, we want to say, as an example I gave, if you are doing some large power consumption devices in your home, then people will know, your neighbors at least will know what kind of activities you are doing, right? Yeah. But then we have a privacy preserving techniques. So by utilizing the batteries, then we can shift the load, and from your home, your neighbor's perspective, they cannot tell what kind of activities you are doing in your home. So if you are interested, you can take a look at my paper over there. And to summarize, I will talk a lot about my research in this part. I will spend a couple of minutes to talk about my research in the rest part a little bit. So this is the research related to the security in autonomous driving. So Tesla's Elon Musk says, okay, human eyes is the same. If human can drive using eyes, they don't need to use other devices like a LiDAR or LiDAR system to do the autonomous driving, right? So, but we find out there's a difference between human eyes and the camera. So especially in the infrared light part. The camera can detect the infrared light, but your human eyes cannot detect it. Then based on that, we can see that we can use the infrared light to create a fake traffic light. So your human eyes will not detect there's a traffic light there, but your vehicles will detect that. Tesla will detect that. They will do accidental stop, and we can also create a fake object. As shown over here, we mount the infrared light over here, and it will create fake objects beside this vehicle. So I will not talk about this in detail in today's talk, but if you are interested, you can take a look at the paper over here. We build a defense mechanism to deal with that as well. And the second autonomous driving related project is also a very interesting one. So this is like we create a smart patch. It's more like you want to sell your house, you put your patch in front of your house, and the autonomous vehicle, they're using cameras, they drive by, they will may like take a different route, because we attract a lot of very interesting, like a key important point. So the autonomous vehicle, when they drive by, they treat this as a very important part, and they will mislead the vehicle to a different route. So it may create a huge damage in some case. And this is the specific design details. I will skip this part. And we evaluated in different scenarios using the vehicle mounted with a camera. And this is the adversary patch we put on the road. And this is the demo. Let me see whether we can play it. Yeah, so we did it in the empty place, and this is the advisory patch, and you can see originally the path should go this way, but it will create the vehicle. If you are using an autonomous vehicle to do the V-slam, they will go to this direction. So another very interesting talk is research is related to like a visible light communication. So over here, if people are talking about 6G, so maybe in the future we can use the visible light to do the communication. And on that part, as shown over here, if Bob is doing Alice and Bob are using the visible light to do the communication, and if we put some small patch, it doesn't need any battery. And this small patch, they have a photodiode on it. It can convert this visible light signal or information and reflect it using the ambient Wi-Fi signals. Then the malicious Eve can sniff your visible light communication. So the advantage over here is like we don't need a battery for this device. So it can be put over there, and you don't need to maintain it, right? And we also did a lot of work for the message authentications in the network part, the jamming, privacy preserving tracking, especially like in, for example, currently people are using surveillance cameras. People will say this will release like privacy information. But in this case, we use the ambient Wi-Fi signals bouncing back on the human body. We can detect who you are based on the walking pattern, the gait of individual person. And we also do the counter jamming techniques. And this is the network traffic anomaly detection, etc. So to summarize, I've done work not only in the sustainable part, we have done a lot of like cybersecurity, smart and connected health, wireless network, big data, and recently I'm working on the quantum computing as well. So I try to summarize, I'm a system researcher. Whenever we build a system, we also consider about the security related topics on that. So for more information, you can visit my website and you can shoot me an email. It's very simple, z.1@osu.edu. Thank you very much. You mean for this one? For the microgrid or? Uh-huh. Uh-huh. How many, you mean turn on the water heater, etc.? Yeah, I think they get on Columbus. I'm not sure because my wife paid for the bills. So but when I was in Maryland, I'm sure they charge based on the time of days. Yeah. Thank you.